Hello, hello, hello. We are going to do another Python programming tutorial today. We're going through the Ciw Python package feature set vis-a-vis its documentation. So today we're going to talk about how to simulate Baulking customers. Now, first of all, what is Baulking? Baulking is when you've got a customer or some unit of flow, an entity that flows, a flowuent or whatever, that is going to be, with some probability, rejected from entering the queue. So this is something where it's not deciding whether it goes into the waiting area part of the queue, the so-called queuing area, but just think about an entire node. Does it enter at all? And if it's rejected, then it just simply doesn't enter and it's removed from the network. So this is distinct in the Ciw Python package from the idea of having a capacity. It's a different programming mechanism under the hood for when you've got a customer and the queue area is already full, so it doesn't enter. That will be considered a rejected record type, whereas a bulk gets its own type. So let's create a programming example. We're going to, as usual, import the Ciw Python package module, and then we're going to create a network, as we almost always do in these tutorials. We're going to say network, and then go Ciw create network using this particular constructor. We need arrival distributions, and I'd say let's keep it pretty simple for this tutorial. We'll go q.dist.exponential, and we'll just go with 1 because I'm not really that interested in covering other aspects. And we're going to do an identical service distribution, or maybe we'll make the service distribution have a higher rate, so it'll be stable. And then we'll also, in almost all of these simulations, we have to say something about the number of servers. We'll just say 1, like it's an MM1 queue, very simple type of queuing system. No problem, but we're going to add one more ingredient. So this is just so far an MM1, but now we're going to add plus, I don't know how you denote this usually, but plus Baulking. How we get Baulking is we need a function that returns a probability of being rejected. You could actually return a Boolean if you wanted to, and that would be interpreted as 0 and 1, I believe. But we're going to do an explicit probability of Baulking, because really that's how the Ciw Python package will interpret this. We need some information about the current state of the queue, and that will be, first of all, an integer representing the number of individuals that are currently on the queue. We're going to have queue itself, which we're going to say is a queue.simulation type. It's the simulation. The next individual, which is the individual that we're considering, whether they get rejected or not rejected, but whether they bulk or not. So we can look at their individual properties, right? So here we can go individual queue, individual, and then next node, which is going to be a instance of the node type. And we're going to return a float type. Now, inside of all of this, we can make up whatever rules we want. So if we look at the Ciw Python package documentation, they have a very simple example of taking the number of the length of the queue. And their rule is if it's strictly less than 3, then there is a 0 probability of Baulking. In other words, they will certainly be added to the queue. Easy peasy. Otherwise, if we've got that it's less than 7, maybe there's another. We're really defining like a piecewise definition of a probability distribution. So if you get past it being strictly less than 3, meaning it's somewhere between 3 and 6, then it's going to be a 50-50 chance for whether they get bulked or not. And otherwise, we will return 1.0, meaning 100% probability that they get bulked. Notice that these are cumulative over the length of the queue length, the queuing area length. And what that ends up meaning is that this is a cumulative probability distribution. It doesn't have to be cumulative. I just wanted to point that out as a little bit of mathematical trivia for you. Okay, so where do you put this in the definition? Well, it turns out that you just need to include this in Baulking functions. And in this case, we can pass in our list for the first node is just our probability of bulking, and we just need the function itself. We don't need to call the function. We should not call the function. And we are actually done in terms of defining this. Now, I will make a little side note that for multi-class networks, which we've covered before in the Ciw Python package, you specify a bulking Python. We're talking about Python functions. Python function for each class and node. So within each class, you would define for each node what its bulking behavior is. We're not going to show that in this particular video, but that's definitely a thing. Here we've just decided that it's a single class, but the multi-class you should be able to pick up from the many examples of multi-classing in the documentation. It's basically a dictionary where the keys are each customer class, and then they map to a list of the function, the bulking function in this case, for each node, where applicable. All right, so let's throw this into a simulation example where we're going to run a simulation. We'll set the seed to 0 just for being able to reproduce this. We'll say our simulation is equal to a instance of simulation that takes our network class, of course. That's always what we do with the Ciw Python package. And then we're going to also grab the records. So we'll take our simulation and get all records. We'll get all of them. And then we're going to, let's see, the tutorial does grab them by their bulk type, but I don't see why. Yes, only, I think we should be able to just pass in only bulk, I believe. We'll give it a try. I believe that's correct, although it's not what the tutorial does. So we'll grab those records, and then we might, let's see, what does this return? Does it return a dictionary? It returns a list. Okay, so that's probably what we want. And then we might, just for the sake of example, print the first record that was a bulk, assuming that a bulk actually occurs. I'm just looking at the tutorial, and they chose some more high rate numbers. Maybe we should too, only because indirectly that will correspond to the number of events. It's not exactly linear, but it's going to be related monotonically. All right, am I missing anything? Yes, we are missing something. We need to actually run the simulation, a very simple but important step that you don't want to miss. So we'll go simulation, and we'll go simulate, and we'll just do until until maximum time has occurred, elapsed as it were, and we'll just go with 100 units of time of whatever that is for whatever makes sense in this context. And we'll just open up a terminal, and we will run our example. And let's see if we can get a better look at this. So we've printed out just the first record. There's actually quite a lot of information about it, and it's a little hard to see in this format. Maybe we could turn it into a table with pandas or on some other data frame library, but this is an entire record that just contains all the stuff. So the ID for this record is 44, which means that there were 43, if I remember right. I can't remember if it's 0 indexed or not. You could check, but it's either 43rd or 44th or 45th or whatever. We'll just say 44. It's the identifier. It's just a unique ID for the number of events. The customer class is still customer. We didn't really do multi-classing, and by default, it's just a customer class called customer. And all this other blah, blah, blah that maybe we have covered in either past videos or that we will cover in a future video. But most importantly, to just look at the type that shows up here, that it's not rejected, which is what you would get if you set a maximum queuing capacity. But here we didn't set a queuing capacity, we set a bulk. Now, one of the things that's an advantage to this is that because they're not treated as the same thing, you can also distinguish them. That one of the things about bulking is that it does not affect reroutes. If you're using rerouting mechanisms, you might get a rejection or not. Let me see, rerouting, well, it depends on at least routing. I'm not sure about if you get somebody who's like kicked out of the service. We might have to look at that. That might be different. But for customers which are just routing from one node to another node, that if they get rejected because of the size of the queue, that is different from bulking, although you might make the probability of bulking also based on the size of the queue. But as we saw, hopefully you got the gist of this, that there's a lot of information in here. So maybe we'll go through and docstring this just a little bit, just so that I make explicit what all these things are or were in our example. So clearly this was an integer. What was this? The number of customers waiting in the queue already. And then we've got capital Q here. I don't know why the tutorial called it Q. They just like to do that. But really, this is the simulation object. It's the simulation instance, I guess we could say. Okay, and then the next ind, which was Q individual, which is the individual that might be balked. And then we also had next node. Oh, come on, Galen. No, I've got caps lock on. There we go. Next node, and that was q.node, and that is the node where the balking might occur. That is the node in the network where the customer might be might fail to enter because of balking. I was going to say rejected, but of course that's kind of reserved for the queuing capacity stuff. Okay, so hopefully that clarifies what all of this is. And to be clear, this float needs to be a probability. So another thing, if you really wanted to do like a, instead is like a probability of balking, we'll set it to none. And instead we'll set, you know, prob is equal to 0.0, or set that prob is equal to 0.5, or set that prob is, actually then we would want to do some if-else stuff, because otherwise we're skipping over stuff. But anyway, the point is, whatever this is, it has to return something that's between 0 and 1. Not necessarily strictly. It could be 0, could be 1, could be anything in between. 1 basically means that it's a certainty, practically in a pseudo-random number generator, leaving aside some mathematical theory about almost events that occur almost never but are not actually impossible, and whatever kind of mathematical blah blah blah. Anyway, so the probability of balking, hopefully that gives you a sense that it can actually be based on many things: the number of customers and really the simulation. And this is where things are kind of interesting. Like if you've got, you know, if you've got a simulation object, you can actually access the nodes, and then inside of the nodes you can access the individuals. So you can actually access all the other individuals in the queuing system, and I think you might also be able to access the servers as well if you wanted to access server information from the node. This is more of like a convenience, I suppose, for how it's implemented, that you pass in some of these pre-assigned things. I'm not sure that it's actually needed. You only really need to pass in the simulation for the minimum information that gets you references to all these other things. But it's food for thought about the design. All right. So if you have any questions about this aspect of balking, of like what it is mathematically, we could do another video about that if you're interested. But otherwise, I would say we can move on to the next tutorial video, and I will catch you next time. Take care.